we are actually streaming right now or not. Hopefully it is going. Yeah, so streaming should have started right now. Fine. Let's start. So today, basically, we shall be doing a revisiting, or rather revisiting the file programming. Okay, first I'd like to ask specifically Dudika, because you are in class 11. Have you got the idea of files in Linux, like the one that I showed you during the beginning of your session? Have you got a good enough idea about that? Like, do you remember what is a
I
file?
don't know.
Do you remember what is actually a file?
No.
Okay, no issues. We can actually go and rediscover everything from the very core. Okay, so let's start. Like here, if I just let's say go to my this folder. Okay, here I have a lot of files. Okay, a lot of CSV, some Python files, some text files, some video. Okay, just don't mind that, but I have a lot of different things. Okay, now to understand what exactly a file is, you can even do this command file. Okay, and then let's say I take something like this one 191 ChatGPT. Okay, think this one. This is a markdown file. So it will say that it is a Unicode text UTF-8 format with very long lines. Okay, that's how this file command works, and it generally prints out the information about that file. Now, say I want to create a file in Linux. How do we create a file? Okay, I think the text is very small. Let me zoom it. It is visible, right? Now the text should be visible. Okay, you guys already know about this command touch. Okay, so I can create touch and then write something like, let's say, file. Okay, so what happened then? A new file got created. So if I do ls minus la, and then I do for the file the name of the file is file. So here, as you can see, I have created a file. Okay, and it is currently containing 0 bytes of data. Now if I just do nvim of that file, okay, this is let's say I write hello HELL, hello world, or something like that. Okay, now let's continue hello world, and I save it. So now if I do that command, you will see that it currently contains 15 bytes of data. There is another command which is called cat. Cat basically means concatenate, and generally concatenate all the output, like whatever is there, into the terminal. Okay, so if you do that, then it will basically print the contents of the file into the terminal. This is very much clear, right? But now, did you notice something? I created a file without any extension, right? So what do you think extensions are? Do you get my question? What do you think extensions are actually? Let me check the audio of the stream. Create a file. Okay, I think the text is very small. Let me. Okay, so the streaming is working. Okay, guys, be serious. So, answer. What do you think extensions are when you see files? Okay, in your Windows or Linux or whatever system it may be. Okay. Can you answer? Or should I just go ahead? Okay. At this point, I'm not getting any responses. So, are you guys shy while answering this on stream? You can even write the answer in the chat as well. That's fine with me. or else I shall just continue, but at least tell me that you guys are there. Okay, you guys are side answering on stream. Okay, fine, that I can understand. So if you guys have any questions, then do let me know. I'm just continuing, okay, so that the flow doesn't get disturbed. Now, so here, whenever you see something like, let's say I created a file, touch file.txt. Now let me do one thing. I do file command on the file. Okay, then you will see this is ASCII text. Then if I do this dot txt, I should have I can do one thing. I can cat the contents of the file and pipe it to file.txt. Now what it does is, let's say now I open the file.txt, you will see that the file.txt has the same content that was there. So basically I took the contents of the first file and put it on the second file, which is file without any extension into the file.txt. Then let's say I do this command. Okay, you will see that both of them are saying the same thing, which is ASCII text, because both of them are being recognized by the operating system to contain text information. Okay, it's not showing that it contains Unicode information, Unicode text. It's showing that it is containing ASCII text. Very good. So if I do touch, then I do file. Now I do MD. Okay, I have created a MD file, markdown file. Then let's say I do the cat command. Okay, and here I cat the contents of the file into the MD file. Now let's do the file command. Okay, let me do the file command. Where is it? Yes, .md. Now it is also showing the Unicode text. That means it's showing the ASCII text. It is being recognized as an ASCII, but not as an Unicode. So how to get it to function as a Unicode? That means it requires a few Unicode characters. Okay, the operating system will automatically recognize it to be a Unicode UTF-8 or 16.5. Let me try one thing. Okay, so let's say I just do a nvim file.md. Sorry, I did a quotation mark there. Let me just end the quote somehow. So this is the file. Now let me just add a simple this. So in markdown, if you do a hash, then it basically means a huge, like the header. Okay, then if I do this, it's still showing ASCII. So if I now do, I have that, I think I forgot, there was something called emoji selector here. I forgot what is the combination. By the way, I am using a config which is should have emoticon all three. Okay, here let's say I take one of the emojis. Okay, then I open the markdown. Then here let's say I paste it. Okay, now if I just, let's say, save it, then I do it. Now you can see that it has changed. So what just happened? Whenever I just pasted a character which is recognized as a Unicode character, then the whole file header somehow has changed. Okay, and it's a very interesting thing, like the file headers. What are those file headers? Okay, let's understand in a deeper manner that we can. Okay, a good example would be to just, let's say, open wait a second, let me just do an ls and see if I have some good files to show you. Something very weird. Let's say I take this svg. Okay, so now in a svg, let me do, what do you think will happen when I open a svg file using a text editor? So any idea? If I open it, you will see the code for that svg file. And because SVGs are actually written in XML format, you will see that this contains a long string of code right here. Okay, it's a single line actually, and this is very long, so let's not go into that. It is giving a lot of headers, okay, to this particular file format. Now let me go out of it what's going to happen if I open a PNG file? See, now open, like, see this particular thing here. It's saying 89 PNG. This is M. M is, I think, control shift or control. This is Z is basically control Z or control enter, if I remember. But yeah, it contains information which is probably not understandable because it contains information in form of binary and a very compact manner. Okay. And understanding this information is almost not possible if you just look at it using a text editor. What happens that PNG contains information in form of pixel information. So it is actually binary. And what happens that this text editors has some buffers. Okay. And those buffers always tend to, let's say, parse the information in a particular file at particular sequences or intervals. Okay. And that is where I was, so I think, where did I keep? I think I forgot. Let me open one more browser here. You can do a simple search like PNG file headers. Okay. And if you just search it up, you will see that here in their documentation, this is the file structure which describes how a PNG file should be written. And here, see, the first 8 bytes of a PNG file always contain the following decimal values: 137, 80, 78, 71, 13. And you know, let me tell you a very, very crazy thing. Okay. Crazy thing in the sense, I met a few people who are Chinese. Okay. And they are researchers, and while conversing, I was just talking about different file formats with, let's say, BF60 and all this. And suddenly file headers came out. So I don't really know the header file for those particular model safe tensors. Okay, so while countering, I was just talking about the safe tensor structure and all this, and this topic somehow came up, that what is the header of that file, and I was like, okay, I don't really know that. These people are crazy. They really remember the file structure in terms of the headers. Okay, these bytes that each file actually contains, they not only help in identification but also helps the operating system understand what particular like application to use for a particular software or particular file. Okay, now you will see that this is the chunk layout, that a 4-byte unsigned integer giving the number of bytes in the chunks data field. This is important because in a particular PNG file, you will see that all the chunks are now divided into 4 bytes unsigned integer strings. And here where the main thing comes. Main thing in the sense, like, as I'm parsing the whole file using a text editor, the chunk sizes that a text editor recognizes is very much different from the chunk sizes a PNG or a, let's say, a image viewer application will understand, because the chunk sizes are very much different. That's why you will see that a text editor might render it in text which is totally gibberish to us. Okay. Hopefully that is now clear with you guys. Now, if that is clear, you can just do, there are different kind of conventions. Okay. Reserve bit and all this. If you want to go into the documentation of PNG, you are totally free to. This is a PNG 1.2. I think there are PNG version 2, 3 or something. 3 I think just now came out. I remember version 3 of some file format just now came out. Okay, I totally forgot. I think it was PNG. Let me confirm it. Okay, let me confirm this. This was actually a news. PNG version 3. Yeah. Yes, this just now came out. Okay. This came out in 24 June 2025, or this is the article that was written. I think it came out in June or July. Okay, it's a very new thing. PNG format 3 just came out. Okay, 20 years later, PNG 3.0 is finally here. Yeah. So that's it. Okay, whatever. Now let's go back to what is actually a file. So now we understood that in each and every file there exists something called file headers, which helps the operating system to understand what kind of format it actually is. Let me also show you this for a PDF. Okay, let me see. I have a PDF. I can see that I have a T. I don't even know what that PDF file is, but let's see. This is a PDF document. Okay, now if I just do a nvim of this, you will see that this now is a PDF of version 1.7, and this PDF has been written very well. Okay, I think this was some mail ID that I made of something. Okay, I don't know, but you can see that this is how a PDF actually looks like. And why is it interesting? The point is this, it is very interesting, is because these also contain headers. Okay, you can just say PDF headers. Okay, for PDF headers, just search it. Okay, think no, it's not good. PDF file headers. It's very difficult for the PDF format. Yet it's very difficult to get it with this search. PHP headers, it basically confuses it to the header of a PDF, like the header term that is currently being used by Microsoft and all these companies to describe the PDF format. It's very difficult to get it though. Do I have it? There must be exactly this format where yes, this is the header where the version number comes in. So this file is rendered in PDF version 1.7. So these are the headers. Okay, and this is how the file basically looks like. Okay, too much stuff done. Now, do you remember the experiment that I showed you where I copied the contents of a file, of a video file, and put it in a weirdly named extension? Do you guys remember that experiment I showed you? Do you guys remember that? I'm just asking. अरे हाँ ना तो बोल दो. क्या हो गया दूतिका? Are you there? Okay. In text, Niket is saying he doesn't remember. So I can show that experiment one more. So it's fine. So if I have, let's say, a video. So let's say go to videos. And here, let me do ls. Let's do some video which is new. Okay. I should have renamed all this, but let me see. Say I take a very small video, this one, 2.3. Okay. So I just copy it. Now, Ctrl+C+V. What happened? Yeah, so it should be the location is now copied. So this is the file. Okay, what I'm going to do is basically take the contents of the file, or better, let me just show you through a text editor first. Now this is how the file actually looks like, which is very weird. Like it's almost binary, but the same thing applies here. The chunk sizes are totally different from how this would be. Okay, now let me go out of it and play the video using VLC so that I can show you that the video is working. So as you can see, the video is actually working. It's also again me doing a screen recording of something. Okay, so this shows that okay, the video is working. Now what I'm going to do, I'm going to basically concatenate, or let's say print out all the contents of that file. So this is the file. I'm going to do a cat. Okay, and then what I'm going to do is put it in the folder random, and let's call it file.video.testing something. Okay, something very weird, something very weird. Let's do that. Oh, sorry. I think I forgot to pipe the contents. Okay, so of course there will be an error. Let me pipe the contents. Now let me go to random. Here, if I do an ls minus la of something, what was the name? File.video.testing. As you can see, it has been recognized as some file. Okay, very good. Now if I do a file of this file dot video, if you do that, you see that the operating system identified it as a MP4 based media file. Okay. Now, how the heck is the operating system doing that? Because it contains the headers for a video file. Hopefully you can understand that. Now, because it is so much interesting, we can do one thing. Because it has been recognized by the operating system as a video file, let's try to pass it to a VLC media player and see if it can actually work. Okay. Let me pass it to, and see the video is working, it's playing. Okay. And that's where the magic of file headers comes in. Hopefully now you can understand what file headers actually mean and what actually is a file. Now, as we have already gone through what is a file and all this, let's now begin the main particular session about the file programming in Python. Okay, we can also do file programming in C language as well. So, because I am also conducting classes simultaneously for C programming for Dutika as well, I shall also record one video for that as when the time comes. Now let's go to the course folder. I forgot what is the folder. Yeah, codes. Then let's go to Python. Yeah, let's open the VS Code for simplicity. It takes a bit for my computer to load up the VS Code. This was some. Yes, this is the file, and let's go to basic files. Okay, I think I should have that. First, file handling. I think I kept that IPYNP somewhere. Is it this one? Totally forgot. File operations. Yes. These are those examples. Now I remember I kept it here. Notebooks. Yes. Now it's there. So, is the font visible? Let me zoom it a bit. Hopefully this is fine. Now, what is a file and understanding file? So we have already gone through the experiments where we have shown you that these are just these extensors. What do they mean? They are basically just suggestions for the humans. Okay. And programs. So, but understand at a deeper level, the operating system is always reading the file headers, and because it is always reading the file headers, you don't necessarily need to actually have the correct extension for the correct file, which is very interesting. Okay, now I've already shown this part. Now I've already given you the example with that at the byte level. Now this will be interesting. Let's do that. Oh, let me select the kernel. It's connecting. Done. Okay. So here, see, hello world. Now in hello, even though you write hello world in form of a text, a string of text, what happens that inside the file, you will see that it is written in raw bytes. Okay. And the file size is only 12 bytes. How is it 12 bytes? Do you know the computation for this 12 bytes? Because there are 12 characters. You can exactly count the number of characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because the file contains only 12 characters, that means each character, of course, you already know that how much space each character takes. It's just 1 byte. And because you already know that, you can simply compute the size of the file that it contains, because it contains a raw string of data. Now, it's all about the content and not extensor. Okay. Yeah, one more important point that I would like to say is sometimes you get emails. Okay, sometimes you get emails, or let's say in your WhatsApp, you might see that someone sent you an image, say .png, JPG or something like that. Now, in that format, you might say, okay, this PNG someone said, and you'll be like, I know this person or whatever, and you try to open it, and then it opens in a browser. Be very suspicious that something is wrong. That even though on .png or .jpg is being shown or .mp4 is being shown on your phone, that doesn't exactly mean that it will contain the information of an image or a video. It might contain something entirely else, or it might contain a website or some phishing link or some malware as well. Okay. Now, these days, Android phones have been particularly good in detecting those kind of malwares, but that doesn't necessarily mean that you are always protected. So, do not open random files which are being sent to you by random strangers. That's the main moral of the story. Now, let's see. What we are going to do, we are going to take the text data. This is a readable text, and then you open a readable.txt file. Now, then you just write the data. Okay, by the way, if you are totally new to everything like file programming, this is the format that we use. I would be going in details about the syntax of it, but I think we can go over the simple syntax very quickly right now. So what is it? So text data is actually a variable which contains the string of data. This is a readable text with the emoticon, or what we say as an emoji. And this basically converts that particular text file from ASCII text to a UTF-8 or a Unicode text. I think I literally showed you the example just a few minutes ago. Then comes this particular syntax, with. Okay, with is a particular Python keyword that opens that basically opens a new whole subsection of commands. Now, with something happening, it will conduct all the following commands with a particular indentation. So, what is the something that is happening? It is opening a file which is called sample files. Under sample files, you will see that readable.txt, and it is opening in a write mode. So there are different modes in Python. I will be going over the modes in Python really quick and really soon, so don't worry. And as you can see, I am also doing it in a UTF-8 format. Okay. And I am opening it as a file object. I think it's called IO wrapper. If I remember correctly, this this is text IO wrapper. Now, in C programming, you will see that these are called as file pointers. Okay, they used to point at a particular location in a file. Okay, but in Python, they have been converted into objects, and basically they have their own class and everything. But this is now a wrapper for a buffer. And what is that buffer? This is the file buffer. Okay, not exactly file buffer per se, but it is called text IO wrapper or something similar. Okay. Now what do? We do a call, like, because it is an object, you do remember that an object can inherit all the functions from its main blueprint, which is the class. So it has inherited the function called write. And what is it writing to that file? It is writing the text table. Okay. Now next format is a binary file. Okay. So basically it contains the information in raw strings. A raw string means raw binary code, and binary, I should say that this, as you can see, this thing is a PNG header file. And you will see that this particular raw string of data you have just now seen when I was scrolling through the PNG header. Let me go back here. This thing. Compare this to whatever you have seen there. Okay, you might see that, okay, I saw 139, it is written 89. What is wrong? The thing is that what you saw there was in decimal. Right now, what you are seeing is in hexadecimal, means base 16. And what you are doing, you are basically opening it in a binary format where you are going to put the strings directly as raw bytes, not with any conversion of ASCII, UTF-8 or anything. You are not doing any conversion. Okay. Now what you do, you have created the file here. Now you can just read back the file by opening the file in the read mode, R mode. Okay, and you, because you have put the data in form of this, the first thing you have put it in form of, let's say, UTF-8, then you need to put the encoding as UTF-8. But let's say for opening this thing, you have you can just use the content and just get the hexadecimal value. See, this is the hexadecimal representation, and you can see that it has written the PNG hexadecimal. Now, how do programs determine the file types? I've shown you different file types, like for PDF, for GIF, and all this. They have different headers, and because they have different headers, you can just run it and be creating those different kinds of file. Okay. Hopefully that kind of gets us to the end of the first module. Then, okay, there is something wrong with this. I remember there was something wrong. Now we will go into the core stuff that is required by, sorry for that. Now I will go into the core stuff which is required by your syllabus, by CBSE syllabus, to understand the different particular file formats. So there are read mode, write mode, append mode, create mode. Okay. What this particular formatting do is, you can just see it here. So basically R stands for read mode. It's the file pointer position. So you know that pointer is basically locating to the first byte of that data for that file. It is now the file position is at the file pointer position is at the beginning. I'm saying this as pointers and again pointers, but again remember that Python has a very different way of doing things, but at the end of the day, Python is also based on C++, so there are similarities under the hood. What is it doing? It tries to open a file, but suppose the file doesn't exist. Will it create the file? The answer is no, it will not create the file. Now say you open it in a write format. It will again go to the beginning of the file. Will it create the file? Yes, it will create the file if the file doesn't exist. Will it truncate it? Yes, it will also truncate it. Append mode means it will open the file at the last ending byte of that file. Say the file already contains some information, say hello world or something. So when you open a file in write format, it might actually overwrite everything. Okay, it will always overwrite the information. So if it already contains, say hello world, and you try to write something like hello, like not hello, say good night. So then the good night will be overwritten over the hello world data. But suppose it is opened in the append mode, then the hello world will always be there, and after that it will say good night. Then there is this X mode, or a special mode, which is basically a create mode. Okay, and it again locates the file pointer at the beginning. Now does it create the file? It's a very interesting thing, because create mode looks for the file existence. It gives an error if the file already exists. Okay, will it truncate it? No, it doesn't truncate. And there are modifiers. Okay, there are two types of modifiers, which is T and B. T stands for text mode. Yeah. If you don't have it in the syllabus, I can't do anything. It is there. Okay, in Python. I'm teaching you. Yeah, আমি আগেও পড়িয়েছি ভাই। X করে দেখিয়েছি। These files. Oh, that PDF. Yeah, that PDF was just a sample. All these notebooks are already given to you, available on my GitHub. You can read all these Python files anytime you want. Okay, at time and time.
Computer science professor.
Yes, in that particular PDF, they have not mentioned it, but that is just for your CBSE syllabus. That is simple. Okay. Here I am trying to go into the depth, and all these files are already available on my GitHub. I can show it to you right now. Okay. Okay, I think we'll directly go to the website. Just a second. Yeah. Let it open. My network is not really that good. Again, it is also streaming, so there might be issues with it. Yeah. So if you just go to the GitHub repository, you can go into the course materials, and here if you go to file and database and go to, I think, basic file programming, or I think it was in advanced. Let me see. I always forget where these things are. Oh, sorry, it is under file operations. Under file operations, go to notebooks. Yeah, these notebooks are already there. Okay, and they have been uploaded like what? 4 months ago. So now duty falls upon you to actually go through the whole code base, okay, and try to read up. There are so much material already there in the GitHub repository for you guys to try out and read. Okay, it's your responsibility to go through the codes and try out with your own creations. Okay, so now let's continue. Because this is a one shot or revisiting the whole concept, I might be a little bit faster. Yeah. So now the first mode is the read mode. Okay. Suppose you got a sample content here. Now there, as you can see, this is a line 1, line 2, line 3 and line 4. Then you basically do a with open the file in the write mode with the encoding of UTF-8. And then you open it as a file wrapper F. Then you basically f.write, it will write the contents, and you can just do a print statement. If this was successful, then only do this. Then you can read the contents of the file, and you can basically also open it in the read mode, or you can do this with a try and accept block as well. Okay, let me do that. I have to again select the kernel, and it has done it. Now look at this error. This is a very important thing. F.write can't write in read mode, because what we are doing here, we are trying to write the contents of some new contents into the file while we are in read mode. You can't do that. Okay, you can't really do that particular part where you are already there, open up the file, but you open up the file in your read mode. So that particular format is only for you to access the data from the file, not modify it or modify anything in the file. Okay, so you are going to face this error, which is very common. Name IO is not defined. Now, what happens when the file doesn't exist? Okay, so suppose the file doesn't exist, then it will show an error. R mode requires the file to exist. But suppose it is with W. W doesn't care. If the file doesn't exist, it will create the file. Okay, that is a write mode. And this is a very interesting thing. Let me just run this. So original text is hello world. This is a sample file. Now wrote the new content. New content is completely replaces the original content. Okay, and then original content was completely erased. Let me see. So let me go to that. I think it's in samples. So one here, samples, and what file is it? It is sample.txt. Let me open. There are too many files here. So yeah, sample.txt. Now let me go back here. Okay, let me just do it through this one. Non-existent and everything. So here I should actually do a print command. Okay. Or wait, I think I missed some part which I did not run. Yeah, this part yes, so now you can see this is the file which was there. Line 1, hello world, this is a sample file. We will use this for testing and all this. So after we have done that, if we open the file in say W or the write mode, and if we just run this command, you will see that the whole contents of the file were edited. Okay. Samjha? Now there is this append mode as well. It basically adds to that file. It's almost the same syntax, just that it will use A instead of W or R. That's it. Now if you go back to here, I think it's a different file. Yeah, this is append test. I think I should open that. This is the file. This is the initial content, and we are basically appending to it. We are appending 3 lines. You can just, for your testing, I can just change it to 30. And let's do that. Let's run it and you will see what happened. So it appended 30 lines to it. Okay. That's the interesting part. Now, this is the X mode or the exclusive creation mode. It will give you an error if the file already exists. If it doesn't exist, that is good. Sometimes you really don't want to overwrite a file which already exists. That's why this mode is very much essential, where you need to create temporary files. So say a temporary file already exists, you probably won't like to do anything to that particular file. So that's why this is very much helpful. And also, not only that, say you are doing some editing to configs. You don't want to do any changes to the pre-existing configs. You would rather actually change the name of the pre-existing config to a new name, or say config underscore backup, and then only create the file. That's why these are very important when you need to do very important file operations, which are necessary for the operating system, or you are editing something in the operating system level, or let's say not even operating system level, but any application level where the application requires the files to exist always. Okay, hopefully that's clear. Now there is also this plus. Now this plus is added to read and write combined, and also there is a plus added to this append mode as well. Okay, let's see actually what this plus do. Say you open it with write mode, but you can actually go and open in the R plus mode as well. Okay, now here where things might be interesting. If you open a file in the R plus mode, it doesn't only mean that you can read it, but you can actually do some modifications to the file. You know that that was not available to you when you opened that file in read mode only, but this is an advanced read mode, or added, or say a read mode with more features. Because now it is a read mode with more features, you can do way more stuff with it. Okay, let's see which what was the file. It's the read write file. If you see the read write text modified, the content we will modify here. So what it does, it first opens it in R plus mode with the encoding as UTF-8. Then it takes the original file and reads it, and then prints it the original file that we will modify. And then it basically moves the cursor f.sig. Okay, f.sig is a very important command that you will see. F.sig basically basically changes the pointer location to any point that you want in the particular file. Here you can see that f.sig bracket 0 basically tells the cursor or the file pointer to move to the front of the file. Now as it tells it to move to the front of the file, and then what we do, we write a modified. So you will see that original got replaced by modified. Finally, we just print the contents. I'm just showing you all the operations. Now, then we have write plus. Okay, it allows you to write and read as well. Okay, now you know that you can do write in write operation. Yeah. What the file? Translate the file. Oh, truncates the file. Okay, good question. Here you're talking about this thing, right? So truncates. No, truncate means to cut. Truncate means to cut. Okay. Now, what does this means? Yeah, what does it mean? Let me tell you. Say you already have a file. Okay. And in that file, the information is already existing, and you want to add new information at particular location. Then can you truncate it? Or means, can you just add it to that particular location by cutting off the previous information? Okay. And that I was showing you, right? I was showing you the plus mode. So in the plus mode, you are allowed to do truncation of the file. Means where it was written original, you truncated it, added the word modified. That's what it means. Okay. Now let's see. We have the W plus mode. It's almost like similar. Now you can see that we can not only do writing, but also we can do reading. Okay. Then there is binary modes, which are B. B basically means that you can add the information in raw bytes. Okay. I'm telling it again that there is a distinction between raw bytes and raw information and the information you add with this cat or whatever you're typing. So whenever you type anything into the file, you are inherently doing a ASCII or UTF-8 conversion that is done by your operating system or the program in which you are typing. But as soon as you mention that you are opening the file in raw format, means whatever you are writing would be given in terms of raw strings. And understand here that because you are writing in raw strings, A, B, C, D, E, F doesn't make any sense to the computer. The only thing that it makes sense is through numbers. So X48, X5, S65, 6C and all this basically translates to hello world in binary bytes. Okay. I should not say binary. It is hexadecimal. Okay. Hopefully that is understandable. You can actually convert it. You know the ASCII code for H. You know the ASCII code for E, L, and just convert it into the decimal and then to the binary. And you will get exactly what I have written here. Then what do? You basically open the file in, okay, this is a test.bin, bin stands for binary, in WB. WB doesn't mean West Bengal, it means writing in binary mode. As you are opening the file in the binary mode and you are basically doing the writing operation with f.write, you are appending, or rather say you are entering or you are creating the file with this new information. Then you are reading the information from the file, and there are two ways you can read. You can read the raw data or you can use .decode option. So if you do .decode, it basically has different encodings. And encoding would be UTF-8, UTF-16 or ASCII or any of those encodings that are available to you. You can read up the documentation on file programming. There are extensive documentation, and Python is one of the very well documented languages that are available in this current era. Now, after that, what do we have? We can open the file in text mode, and in the text mode, we can write the information as well with a UTF-8 conversion or not conversion, encoding. Then we can write in binary mode, we can do both, and then we can even compare. So what are the results? You wrote the something in binary data. So B, if you see something like this B followed by this hello world, that B basically means that these are raw bytes or raw data. After that, what do we have? We basically read the binary data in raw format and then we basically decoded the textual information. Okay. Fine. Hopefully this is clear. Then what do we have? Text mode result, hello world and all this. These are there. Next we have practical mode selection guide. So what do we do here? Say these are actually particular examples where the mode selection for a particular file writing means a lot. These are mission critical information that you need to have when you are doing all this file reading and writing in a developmental environment or in a production environment. Okay. Because your choice of mode might actually mean a lot. Okay. Say these are examples. Say you want to read from a configuration file. Okay. And the configuration content is like this. And then you will try to open this config in a W format. Okay. Say you want to do it in read format. The point is that what should be the best way of doing it? Okay. The answer is C. If I go back here, reading from a configuration file, which is here, mode R. Always choose R, not W, because you might overwrite whatever was already pre-existing in that particular file format. Okay. Hopefully that is clear. Then suppose you are writing a report, and in report it generally doesn't make sense for you to rewrite whatever was there in the old information. So unless and until it is necessary for you to write the report over over the previous information, you would not choose W mode. You would always choose append mode, that is adding new entries. Okay. Even for log file, you will also do a more entries. Okay. Suppose I already told you about creation of unique file, then always choose the X mode or the exclusive mode. Okay. That will not create a file if it already exists and will throw out an error. Next, we have counter files. Okay. Here you will see that f.truncate. Okay. Remember, I told you that truncate is generally supported by R plus and all this. So you can use the f.truncate operation as well, which removes any leftover content after you added new information. Okay. Now, after that, what do we have? We have the copying from a binary file. Here you can actually copy the information from a binary PNG and copy it to a new PNG as well. Okay. Now these are common mode mistakes and how to avoid them. So suppose you basically are using W when you meant append. This is a very common example where then what happens, you will lose all the information that was already there in your file. And you really don't want to lose the information that was already there. That's why you need to be very much careful while choosing what kind of mode you will use while adding new information to the particular file that you are using. Now, after that, you can see a lot of examples that have been laid out for you. And this is a summary for you as well. And please read this. This table is very much important. And this is not only important for your, say, day-to-day life, but also for your exams. So if I say that it is important for your CBSE exam, then only you guys will be reading it, right? So understand that this is actually very much important for your exams, and they might ask you to write the differences between a read mode and a write mode, or a read mode and a write plus mode, and all this. Okay. And a better addition to that differences would be in which use cases you will be using this kind of formats. So that adds another layer of sophistication and understanding that you already have over the choice of the file formats that you will be doing in your production or developmental environments in your future. Now, there are other things that I would say. This is working with the existing examples that we have. So these are from the class 2.py. I think I've already taken these classes many times, but because we are revisiting them again and again, we can do this here. I've already gone to this pickle size I haven't gone through. Okay, performance analysis, yes. So I need to go through this part. Do we have anything else? No. Let's start. Let me select the kernel. Yeah. So I will append the examples. Okay, now here, no such file. What happened? Oh yeah, of course. These are just showing you the different errors that you will get. This is fine. Now, here the performance analysis. This is from the class 2.py. I think I still have it somewhere. This is, I think, yeah. This is the example where we were doing a lot of different stuff with this. So suppose you have pickle. Okay, let me show you what this. So what is pickle? Let me go to the browser. Pickle package. Pickle is a very important package in Python, which we use for reading and writing binary information. There is this operation called pickling, or for serialization, and unpickling for deserialization. What do we mean by serialization? It basically converts a Python objects into a byte stream. Now, this byte stream can be stored in a file, transmitted across a network, or used for inter-process communication. Now, what is a byte stream? Stream, not a string, sorry. A byte stream, you can, I think I have a few visualization. Let me see. Okay, yeah. I don't know why it just suddenly showed me some x-rays. Yeah. It is loading. Hopefully it will load within time. This is also another good example. Okay, I don't know why it is not loading, but hopefully you can do with this poor quality of the image. See, suppose there is an application. Now it wants to send the data. So the data needs to be sent through packages. Okay. Now this packages needs to be ordered. Okay. Ordered means there needs to be a particular order in the data package. Say roll number 1 will go first, roll number 2 will go the next, then 3, then 4, then 5, and 6 and 7. So that way of serializing the data packets in 1, 2, 3, 4 or order is called a byte stream. Why do we call it byte? Because these are basically raw information that are stored in bytes. And yeah, that's how generally it means. And I think there is this visualization as well. We can load up. This is a network visualization of byte streams which are flowing through a network. Okay, Azure system, from mobile, from generic input, or from Salesforce and all this. Okay, then these byte streams are very much crucial to be controlled. You don't want any loss when you are transmitting a byte stream. Okay, I think this is this is a medium what do you call this, blog over the byte stream. It's a blog that was written by Zach West around 2020, and it's a 4-minute read, which is good. Now these are bytes. This is, and each memory memory block contains 1 bit of data, and 8 bits contain 1 byte. Not contain means 1 byte, and this is a byte stream. See, this is the ASCII character CODE, and these are their corresponding decimal values: 99, 111, 100, and 101. Here you can see that this is streaming because it is currently in a serialized format, and you are reading it from left to right. This kind of serialization of raw input bytes or raw bytes is being done by this pickle package, which is available in Python. Next, we have JSON, we have time, and OS. Already done, not going into that. So what happens here? As you can see, what we did, we created a function which is enhance pickle versus text comparison function. Here we try to compare between the latency that, say, a text data has. Say this is our text data in form of a dictionary. Okay, and suppose this contains the information of users. Then this is enhance pickle versus text comparison. Then you create a pickle file, enhance data.pickle, PKL. Then you use the pickle write. So you open the file in the raw binary format, write binary format, and you dump the information. Then you just do a pickle write time, the time start and time.time, then start. So these are time package options that you have. Time.time basically means that you can get the timing at which this process started and store it into a variable called start time, and then you can get the end time by just basically final time minus initial time. Then this is the same way you can do the read application, and now you can do the JSON1, JSON read as well. And as I just ran it, you can see the differences in the performance. Okay, the pickle write operation took 0.000767 and the JSON write operation took 0.009923. So it is about 10 to 12 times faster than your JSON writing and reading operation. That's why 10 to 12 times you might see that these are in by 0.00 seconds and all this. This is a very, very small file. Because it is a very, very small file, you won't actually notice the differences that much, but understand that this is actually 10 to 12 times faster, which is a huge difference when you have let's say files in terms of gigabytes or terabytes. Okay, you would be, if you guys actually work in say IT or engineering or say even in research, you would be handling data which are in gigabytes, in terabytes. Okay, and when you are handling data, you do need to save out that time on research and the computation time. That's why these tools are there that will help you to reduce your computation time by reducing the time to read and write files and all this thing. Okay. Now you can see there's a file size comparison as well. A JSON file takes about almost 99 or less than 1000 bytes. Okay, it's like 100k bytes, whereas it's like what 30k bytes. Okay, which is very like 3 times differences. Okay. And these are the preview. Pickle binary looks like this. Okay, this is the stream of that particular information that you just saw. Okay. Now, then we have the file seeking operations. Okay. Think there was an error with this. Seek demo. Oh, seek demo was not created. It's fine because these are old files. They are not there. Let me see from. Can I import? Yeah, this import. Remember these imports, these are basically analysis homework and everything that I just gave you. These are the functions that are already there written in the previous file. You can go back and check out the functions. I'm just basically taking the, yeah, these are homeworks that were given to you. The count the number of words, count the number of lines, count the number of characters, count the sequences. Yes, you. Yeah, good. Now you can also flex your GitHub as well. Good. So yeah, these. I don't know. I asked them to do it. I need to. They're not in dummy school, but they are in a school where they go to school, but not every day. Like, bro, it is a bit different. I don't know why they don't go to school that much, but Somojit and Angs, they are actually trying. Okay. But I feel like they are not doing that much. Okay. Whatever. These are the homework. I think these homework answers are already there. If they have tried, I would like everyone to try it. Okay. For Dutika, are you there? Is he here? Hana boldo? Yeah. Okay. Okay. So for you, try to do all this without looking at the answers. Okay. Basically, count the number of words in a particular file, count the number of lines in a file, count the characters in a file, count the number of sentences in a file, vowels, consonants, uppercase characters, digits, spaces, tabs, new lines, punctuation. The homework answers are already given, but try it out by yourself. Okay. And I know you have already done all this without the file programming because you have done it in form of, let's say, string. Okay. But now, can you do this in form of file programming? Okay, by the way, do you have any questions till now? Okay. Are you able to understand everything?
I guess.
Okay. If you have any questions, you can ask me later or even now, because I think you need a little bit of practice to get into all this file programming. So try doing this as a homework. Okay. These are file independence and yeah.
বলছি ওরা দুজনেই কি বিহারে থাকে?
No, only Angs lives in Bihar. Okay. Like he used to be here. Angs used to be here, and I think his home is in Bihar. Okay. Let's continue. So we have demonstrated this is a file extension independence, which basically I want to show you that extension doesn't mean anything, to be very honest. Okay. Like previously also I showed you that whatever be .mp4, .mp3, whatever, if the headers and the file information is correct, then it doesn't mean to like have some extension. But these are actually for the good of humans, so that normal people, humans, okay, they don't mess up while doing all this. Okay. Now let's see what actually we are doing. We are trying to create different fake png.txt.doc.mp3, and then we are going to open and basically read and demonstrate. So let's do it. See, created files with identical contents, even though it contains .text, .random world, .fake video, not an image. Okay, whatever. It really doesn't make any sense. Okay, any extension that you have. Okay, they won't be making much sense, but still you can see that the content inside those files matched. Okay, now you will see that you can do this same thing with binary files as well. The signature will okay, these are operations with respect to large files. Okay, and processing technique. Let me see if everything is working. Everything is working. So let's go a little bit. Okay, we will end it after this. Oh no, we need to do the CSV. So after this, we will do the CSV and then we will end it. So this is a efficient processing demonstration. Say we want to have a very efficient process. Say this is the large file that you have. Then what you are going to do, you are first going to say this is the sample content for processing the information. This is just a sample file that we are creating. Now we can process the information line by line, which is memory efficient. Now here comes a technique which we call as parallelization. Okay, but that means you are going to parallelize the whole process upon multiple cores. Okay, say you have 12 cores, then you are going to run, say, the line 1 on the core 0, or say line 0 on core 0, or line 1 on core 1, line 2 on core 2. Okay, so that way you can parallelize the process. Okay, so that you can make your whole computing way more efficient that you could have ever had. And this not only makes your computing faster, but also utilizes whatever resources you have. And also there is this power draw. The concept of power draw basically means that, say you are anyway using, say, how much I can, say you are using 10 watts of power, okay, for running the processor. And if the processor runs on all the cores, it uses, say, 30 watts of power. But now the process has increased in efficiency by 12 times or 16 times. Then that basically means the increase in power by 3 times resulted in the increase in the processing power or computing power by 12 times, which is a very good ROI or return on investment. Okay. Now, after that, what do we have? Let me see. Say, yeah, we were going by line count, right? So these are just simply opening the files, and you know this time.time module. So we are just taking the time of the initial process and the basically final process minus the initial time, and doing that in simple opening files using R command or the R mode. Now, suppose we want to process it in chunks for binary when you need more control. Okay. Now you can actually size up the chunk. Remember I told you about this byte stream. In this byte stream, as you can see, the chunks are of 1 byte. But your processor can handle, your cache can handle more than 1 byte. Say it can handle up to, let's say, 4 kilobytes. Okay, something like that. Then you can just take that much chunk. See, I took the chunk size as 4 kilobytes. Now understand that because this is a Python program, there will be an interplay between the cache and the RAM. Okay, it is not a C program. A C program will be able to control the memory in the cache as well as the memory in the RAM. So a C program will have a way more control over the hardware, but again, you need to be very let's say knowledgeable over understanding the different flags to control the L1 cache, L2 cache, and L3 cache. Okay. Now in Python, to be very honest, I don't know where this particular chunks go. I hope that it goes into the cache, but knowing my past experiences, why do I feel like it will go into the RAM? This is where the curse of abstraction comes in, because everything here you can see that, okay, it broke down into chunks and it will be processed into chunks, it will be faster and everything. That is a very simple concept to understand. But what is not easy to understand is where these chunks are actually going. For that, you need to read not only the documentation, even the documentation sometimes doesn't contain that where these particular chunks are actually going. For that, you need to sometimes even look into the whole implementation of this particular file. Okay, and which is not something that you can do every time now and then. Okay, but we can actually go into the pickle documentation. Here you can see the object serialization and all this. Okay, and here if you want we can go and read it, and if we can find it, it will be very good. Okay, but yeah, if you're going to ask me where these are stored, I don't know. I seriously don't know. I have to read up, but that's it. Now let's see. Let's continue. Now we are opening the large file in the binary form because we are using pickle. Okay, and while the condition is true, what we are going to do, we are going to read the chunk in form of these chunk sizes, and then what are we going to do? We are basically going to see that if this is not a chunk, then we are going to break out of the loop, and if everything is working fine, yeah.
তোমাকে বেসিক ডিফারেন্স বলো তো, ব্রেক কন্টিনিউ পাস তিনটে বেসিক ডিফারেন্স বলো।
কি continue? আচ্ছা, break, continue and PA is the past.
পাস PA double S.
Oh, pass. Acha, okay. Yeah, that I can say. Don't worry. Should I do it here? Let me. কি কেটে যাচ্ছে?
সব সময়।
See. Go into the Python terminal. Now say I have a if something, say if true. Okay. So if the condition is true, and then you can break out of it. Okay, it's a very like weird thing. Okay, this is outside the loop. Did I wrote it outside the loop? Oh yeah,
Capital.
yeah. Sorry. Is it capital?
not
No, true.
small.
True.
Oh, okay. That's why.
ক্যাপিটাল হবে।
Yeah. True. You guys are true. Something. So basically, this is not a loop actually. I can do it with a loop. So say for I in range something like, let's say 5. Okay, but I do need to define this. So now let's say print. Say I just do I. Okay. So it will just print the numbers. Now if I just go back here and say yeah, why is it in the nice one. Okay. Now if I just do a break, see, did anything happen? Was it able to print out anything? No, because
No.
in that loop itself it broke out. Okay, whenever it
হচ্ছে লুপ থেকে বেরিয়ে যাচ্ছে ডাইরেক্ট, আর নিচে স্টেটমেন্ট
no whenever it encounters the statement break, it will break out of the loop. Okay, it will not continue. Now here if I, instead of let's say break, I do continue. Okay, then yeah, what happened?
একই তো ব্যাপার।
But there were some differences. Can you tell me?
আমাকে জিজ্ঞেস করো, আমি নিজেই ঘেঁটে বসে
It went through the whole loop, but it could not print anything because at every step it continued.
Yes, it just continued. Basically it went and then it never did anything. Okay,
আর তো কন্টিনিউ তো প্রিন্ট স্টেটমেন্টটা তো নিচে আছে, ও তো প্রিন্ট করবে। লাইক ও তো লুপ থেকে বেরিয়ে যাচ্ছে, লাইক i equal to 0 যখন i equal to change হচ্ছে,
I get it, but
মানে তো প্রিন্ট করবে।
Dudika, can you answer?
বুঝতে পারছি না।
Can you answer
Can you
this?
repeat?
Can you answer this? Niket, ask the question properly. It's a very fundamental one.
হচ্ছে the কন্টিনিউ স্টেটমেন্টে কন্টিনিউ মানে হচ্ছে লাইক এগিয়ে যাওয়া, তো মানে পাতি ভাষা। সো প্রিন্ট স্টেটমেন্ট তো কন্টিনিউ নিচে আছে, তো ইট উইল মানে প্রিন্ট তো করা উচিত, লাইক ব্রেক স্টেটমেন্ট তো না যে নিচে স্টেটমেন্ট গুলো কেউ দেখবেই না, লুপ থেকে বাইরে বেরিয়ে যাবে। তো কন্টিনিউ মানে তো নিচে প্রিন্ট স্টেটমেন্টটা তো অ্যাকচুয়ালি মানে দেখা প্রিন্ট তো করা উচিত।
So what is happening? Why is it
But
not
হচ্ছে
working?
না,
That's what.
কারণটা কি?
Yeah, that I am asking you. Can you
আমি
somehow
নিজেই তো
understand?
জানি না।
Can you somehow devise an experiment to understand what is actually happening? Say you don't know, you
না,
don't
দেখো,
want to
break
read up
statement টা বুঝে
documentation.
গেছি।
Break you understood, right? It basically broke down there.
হ্যাঁ, ব্রোক
Then
ডাউন ঠিক আছে, কিন্তু কন্টিনিউটা কি হচ্ছে? মানে কন্টিনিউটা লাইক নিচে প্রিন্ট স্টেটমেন্টটা আছে, তো তো কন্টিনিউ মানে তো প্রিন্টটাও তো প্রিন্ট করবে।
yes, but continue
তাহলে
what
প্রিন্ট
it
করছে
does.
না কেন?
It tells the function to continue from whatever is outside. So let me tell you. Say, I think both of these will behave in a similar manner. So that's the difficult part. Say there is something let's say print hello.
আর তুমি এমন একটা জিনিস দেখো যেখানে ডিফারেন্সিয়েট করা যাবে।
Oh, yeah, correct. Now what happened? Continue basically told Python or like this function that okay, you can continue, okay, and skip rest of whatever is there in the loop. Okay, fine.
But that will also work for a break also.
That will also basically happen for break. Okay, that's the point. Let me think. Let me think. Yeah, let me think of a good example.
Continue.
If দিয়ে actually ভালো হবে, but if দিয়ে কি একটা দেওয়া যায়?
If I equals to 4, no, if I equals to 3, continue.
I equals to 3 continue. That basically continue needs that. No, that won't be a good actually. Give me one second. Let me think. How to show a good difference here? Yeah, I think I can actually use your idea there. Let me do one thing. Say I have this same particular range function, okay, but here what I do, I add
equal to 3 করলে প্রিন্ট হ্যালো।
if let's say I equal to 3 or 2, okay, whatever you want to use, but here what I'm going to do, go here and write continue. Okay, fine, and then I'm going to do a print I. Now what do you think would be the output of this?
1, 3, 4.
Correct. Let's do that. 0, 1, 3, 4. So what actually happened here?
কাজটা সেই হচ্ছে,
Yes.
এক্সিকিউট করছে না।
This
I
is
equal
this
to
is
যখন 2 হলো,
yes. Let's do that. 1 and 2.
ও বাবা,
So what is happening here?
I equal তোমার 2 এর পর আর লুপ আর এগোচ্ছেই না।
Because it broke out of that whole loop. Okay, but continue never, like, it never told the function to break up. Yeah, it told to continue execution of the loop. Okay.
ঠিক আছে, এবার তুমি বলো পাস।
Yeah, pass is a different thing. Say you have a function. Okay, say you have function, say fun1. Okay, and say you want to do something. Say you have not decided what to do with this function. Okay, and then you say you want to call this fun1 function. Okay, then you are going to basically face an error. Now suppose you write pass. Sorry. See, there are no errors. What actually happened, this allowed the function which has still not been devised, like what to do with this function. Okay, Like what to do means what is the return type, what to even return, what is the function of this function. Okay, nothing has been decided. Then you use this pass keyword to let the function exist and not do anything. Okay. Let me think. Can I actually use pass? I think I can actually use pass though. But let's actually try. I haven't actually done it like that. Good question. Let's try. Let's try this example. Yeah. So instead of break, let's just use pass. Okay. Let's see what happens. Sorry. It just let it exist. Okay. It basically does nothing. It basically does nothing. Okay. It lets the loop continue normally. Okay. If else में उतना कुछ काम का नहीं है. It only works very well when you have to. Yeah. Correct.
আর ব্রেক এন্ড কন্টিনিউ কোনো সিগনিফিকেন্স ফাংশনস নেই, শুধু ইফ এলস স্টেটমেন্ট, তাই তো?
You can also use break in your functions as well, like if you have if, for, and all those loop. Say your function itself has for loop, if loop, and if conditional and all this. Okay.
If loop.
sorry, if conditionals. Okay. So yeah. Now let's continue what we were doing. That was the chunking and everything, right? So you have this large. I already talked about this chunking and caching and all this. Oh, by the way, one more thing. You guys already know about this caching, right? Let me show you this. So if I go to my, where is it? Yes, this is. As you can see that these are my caches. This is L1D cache, it is L1I cache, L2 cache, and L3 cache. So these are my cache, let's say, not limit, what I can say? Amount. The amount of cache that is there. It is 352 kilobytes, or not even kilobytes, it's kibibyte. Okay. Remember that there is a difference between kibibyte and kilobyte. Kilobyte means it is with respect to 10 base number. Okay. Whereas kibibyte or megabyte or gigabyte means that it is with respect to 2. Means whenever we send a 1 gigabyte, okay, we generally think that it should be like 2 to the power 10, which is 1000. Yeah, which is 1024, right? But the actual term should be used as gigabyte. A gigabyte basically means 10 to the power 3. Okay. Hopefully that difference is clear, and these are the caches. And what I was talking about, this chunking. Okay, so what happens in Python under the hood, I don't really know where these chunks are actually stored, but these are done to enhance the performance. Okay, because the concept is very simple. You're not processing the whole file together, you're processing each chunks or each data streams. Okay, in here byte streams. That is the main crux of basically enhancing the performances. Okay. Now after that, what do we have? You can process all these chunks and you can take the time. Okay. And this is the most memory efficient method would be the third method, which is a generator based processing. Okay. What is a generator based processing? Say you basically do an enumerate of the each file path. Okay. Then you know that which file actually is where, and then you take the line number, length, and all this. It basically generates that how much data needs to be processed at each instance. Okay. Instead of doing a hard coding that, okay, I'm always going to process 4 kilobyte, I'm always going to process this much. It makes it dynamic such that it will process the information smartly. Okay. It will process each line and then yield the result. And you know, this can be way more enhanced when you combine it with parallel processing. If you combine it with parallel processing, it becomes way more enhanced. Okay. You can see that these are the time taken is like 0.006, 0.000 seconds and all this. Okay. Understand that these are not very large files. In reality, large files would contain like gigabyte and terabytes of data. Okay, this is done. Next, the last thing which we have on our plates for today is CSV file operation. Okay, so for CSV file operation, you will import this module, which is import CSV, comma separated values. Okay, and there is another format which is TSV. What will be the full form of TSV? That means tab separated values. CSV, TSV, whatever be any other format. JSON is basically a Python dictionaries, not separated by anything. Okay. Now here you can see you can create a simple CSV file. Okay. There is already a CSV which you basically print using, okay, this is, who can tell me this thing? This is called, what this is called? List comprehension, right? And this is actually a Pythonic way of doing it. Why do I say Pythonic way? Because in a single line, I compressed 3 lines of Python code. Okay. So what it does, it finds those attributes for each attribute in this particular directory having the CSV file, where the directory does not start with this minus like underscore. Okay. This is the whole logic, and these are things, the dialect and all this, whatever be it in the reading. Now what we are going to do, we are going to basically write CSV file. How do we write CSV file? There is actually, okay, first we have this simple list of lists, and there are different functions. There are 2 different main methods of writing to a CSV. One would be using the list of lists, and one would be using the CSV dictionary. Okay, which basically reads the information from a dictionary. Okay, Python dictionary. Here you can use the csv.writer, just like you use the like f.write, you can use csv.writer to write to a CSV file. And what you are writing the information which is this thing, employee data. Where is it? Yeah, this is the employee data. Okay, and first, okay, by the way, this is not exactly the same. In your IO wrapper for f or file, you used f.write and directly put the thing that you need to write. Here you can see that first you need to create an object, for a writer object. Okay, and then using that writer object, you need to use a member function of that writer object, which is write rows. And using that member function, you are writing the information into that file. Okay, so this syntax is a little bit different from your Python IO text IO wrapper, but at the end of the day, this is very, very similar. Okay, so it's not matter for you guys to differentiate much in between these two. Of course, under the hood, there are differences. Their parsing is different. Okay, that's it. The lexical operations which are going on is different, but that you don't need to worry much. Now, verify that the Python file. Oh, okay. Lexical, basically, I'm telling you, give me 1 minute. Lexical operations. Let's say in C. I think C has better documentation on the lexical operations. Yes, this is the lexical analyzer. So you know that C has this compiler like Clang and also GCC and all this, right? So what happens when you write a program? So when you write a program, it's written in English, right? So English is a language which is not directly understood by your compiler, or sorry, not a compiler, by your machine, by your PC. So a lexical analyzer basically takes the code that you have written in simple English language, and then it tries to analyze what each keyword actually means. Because each keyword, say keyword, I think I can have any, I think this is a good example here. See, if then the bracket opens, then x is greater than 3.1 and all this. Okay, then the lexical analyzer will basically take all the chunks together. It will basically parse it through a strings. Okay, it will parse each string and then understand that is, let's say in its head, it will go like if is actually a keyword. This is a bracket. So then inside the bracket, there will be a conditional. Where is that conditional located? Okay, this is the job of the lexical analyzer, to understand where you have written the handwritten English code and where those keywords are, where those constants are, where those variables are, what are those variables and everything. Okay, the lexical analyzer is one of the very first things that your compiler uses when you just pass your handwritten code to it. Okay. Or AI generated code, whatever it be. Okay. Now, what I was saying is that this analyzer, lexical analyzer for your file pointer is very much different for the lexical analyzer for your CSV file. Okay. Now, thanks for catching up, asking that question, because I never actually explained it fully in your previous classes. So thanks. Now, even right now also I'm not analyzing, or let's say describing how lexical analyzers work, because that will be too much deeper into the understanding how compilers work. Okay. Now, what do we have? We have to show the content. Okay. Now we can show the content with a simple file.read. Okay. Which is how we do it. And yeah, you can just take the information and just write the file. It's very simple. Let me run this code. So as you can see, this information was written, and then it was written in this particular comma separated values or CSV format. Then alternative writing row by row, you can also do this row by row, you can write. Okay. Then as I told you before, that there are two different ways of writing to a CSV. One would be using the list of lists, and another is using a list of dictionaries. So here we are using a dictionary, and you can use the CSV dictionary writer, CSV writer. Okay. And this dictionary writer will basically parse all this information. And this is again, I'm telling you, this is another part where your lexical analyzer comes in. It analyzes what you have written in this list of the dictionaries and parses it to properly understand what to put in the what to put in this particular CSV file. And that happens under the hood without you doing anything. Just understand. In C programming language, you had to basically understand that how CSV file format is written, and then you manually had to do the comma separation, %t, %n, sorry, %t, \n, and all this. Okay. And let's just understand that Python makes your life way easier while doing this program. You don't need to worry about this analyzing, lexical analysis and all this. Okay, whatever. Now you have the dictionary writer, which is again, you will create a writer object, then basically use the write header. So write header in a CSV means that these dictionaries need to be extracted for the header: ID, name, price, and stock. These basically constitute the header here. ID, name, department, salary, join date. This is the CSV header. Okay. Once that this is done, you basically write all the data, and after that you basically show the content of the file and print it. That's all it is. Okay. The syntax is very clear, and as you can see, this is how it looks. Then suppose you want to read CSV. So till now I have shown you how to read the CSV using a file reading, like read using f.read. But there is actually a CSV reader as well. So CSV.reader, you can use it to read. Again, remember, just like in the writing operation, you had to do a writer object. Here you need to create a reader object. Okay, by using CSV.reader member function, and it takes the argument of the file text IO wrapper for that particular file that you want to read, for that particular CSV file that you want to read. Okay. Now you basically extract the header and then take the information, and then because the information comes in form of a enumerated list, you can simply use the enumerate to take the row information, and each information you can just print out separately using a simple for loop. Okay. And alternatively, you can actually just print out all the whatever is there inside that loop information directly without much of the loop. Okay. That is there, and this is some calculation that you can do. Let me just run this code. As you can see, I can just take the header here, and then this is the employee data. Alternatively, you can just all read everything at once. Okay, I'm just printing the first particular information, which is about Alice Johnson, which is from engineering department, and some salary or something is there. Okay, that's it. Now there is also, this is an example, just example, may not even exist as a person. These are just examples. These are examples. I can write Bhavesh, Suresh, Ramesh, whatever I do. These are standard examples. Next is using CSV.dictionary reader. Just like we use the dot reader member function, there is also the dictionary writer member function. There is also its counterpart dot dictionary reader as well. And here we can actually read it using the dot dictionary reader. These are a few advanced operations where we create a TSV file from a CSV file. Okay, TSV basically means tab separated file. Okay. So as you can see, instead of using a CSV, we use the TSV. Let me see if I can show you the TSV as well. So in the examples, I think, sorry, not here. Can you see the TSV? Give me one moment. Let me see what's the name of the file again. Here. This is samples ts course dot yeah, this is here. So I messed it up. So this my this reopen editor with a text editor. So as you can see that the information that is written, the information written here is separated by 4 spaces. Okay, and 4 spaces corresponded to 1 tab. Okay, so this is a TSV file format. Okay, let's go back. What did we do? We took the TSV data in form of a list of lists. Then we just basically took the CSV writer. But here, how to create a TSV? Basically, the delimiter means the separator between each cell of the information. The delimiter, you need to change it from comma to \t. \t stands for your tab. Okay, that's it. That's the only change you need to do, and everything is totally the same. See, everything is the same. Even for, let's say, reader, just put the delimiter as \t. You will be able to read from a TSV file. Now you can do a custom quotation. Okay, by using quoting equal to csv.quote all. It quotes. What do you mean by quote? Quote means it will basically put every cell or every information in the CSV file inside quotation marks, double quotation marks. Okay, that means it will convert the information into strings. Okay, sometimes it is very much required to actually have string information for, let's say, big data analysis and parsing. That's where this kind of things are very much important. Now, you can basically show the raw content without the quotes and even read it back normally just by using this particular formatting. Okay, then there is also some, like, says with dialects. So which are some dialects? Delimiter you can put as, what do you call this, front/dash, vertical dash. Okay, you can put the quotation mark of double quotes instead of single quote. You can use the quotation quote minimal. Then you can use the line terminator as \t. Line terminator means, say, you have this TSV file. As you can see that the TSV file here, from here to here, why did it go to a new line? Because the line terminator was set to \t, and \t basically means a new line character. That's why this is the line terminator. Then we have the custom data.
Slash, ওটা কোথায় গো? Keyboard কোথায়?
This is, on your keyboard, look at the key right above the enter key. If you press shift and the key which is above the enter key, you will get a vertical slash. Given enter key এর উপর,
Enter key এর উপর backspace আছে।
enter key के ऊपर backspace है, सही से देख, उसके ऊपर एक और की है जिसमें तू front slash देता है।
front slash, तो मैं छोड़ दिले बड़ा।
Okay, next let's. So we have, suppose, some custom data. Okay, this is that custom data. We can create a custom format as well. This is, let's say, our customized CSV format. Okay, and let's see how it looks. Let me open it in the CV open but editor.
আরে আমার
It is-
ল্যাপটপের কিবোর্ডটাই আছে বাট এক্সটার্নাল কিবোর্ডটাই নেই।
See here the separator is a front slash instead of a let's say comma or tab or anything. Okay, this is a custom format and you can create your own custom format based on your own needs. Okay, fine. And these are a few error handling. Basically you need to always convert, encoding must be correct. Okay, and you must always try to put your CSV reading commands in a try and accept block. Okay, it is a good habit to do that. It is always a good habit to do that. Okay, these are some file manipulation. Okay, and these are some analysis examples. You can go through that. These are not very much difficult. Whatever we did previously, these are just the extended examples of using CSV. Okay, so all these files are already available to you. Let me solve the issue what Niket is facing. Okay, with his keyboard. Let's see if he has sent the picture. Oh wow. Oh yeah, it is just it's fine. So see,
কিবোর্ডে নেই।
see. This is the
আরে
front.
স্যার তুমি আমার নাম্বার
This one.
দিও না আবার সবাইকে
And this is. See, this is that front slash. Okay, and then after this, this is
আচ্ছা আচ্ছা ওটা কাটা আছে ভাই আমি খেয়াল
yeah. On a few keyboards, it might be like broken. Okay, it's fine.
ঠিক আছে।
Okay, I think this is where we would like to conclude. Majority of the file operations and CSV file writing and everything has been properly discussed. You are free to go into the GitHub repository where you can explore more into the programs that have already been given to you. And if you guys have any questions, you can ask away. So do you have any doubts, questions or kuch bhi?
হ্যাঁ আমার প্রজেক্ট আমার
Oh yeah, project. Okay, then I shall end the stream and then we can discuss about the project. Dutika, do you have any questions or any place where you felt like you are not understanding?
Not yet.
Not yet. Good. So can I ask you to practice and do the homework? Okay, where you open up files and count the characters, spaces, upper character, lowercase character, and all this. Okay, do that homework, and I am ending the stream right now so that at least you can be a bit more free.